So now that we've talked a bit about what factory methods are, and I showed you supplyAsync and I showed you runAsync, let's take a closer look at how you might apply the supplyAsync model, since, as I mentioned before, it's by far the most common. And you can see that there's really only a handful of factory methods, but they're very important because nothing else really starts, for the most part, unless you use them. So here's a reimplementation of the earlier version of the BigFraction multiplication program, except this time we're going to be using CompletableFuture with supplyAsync as opposed to having a incomplete CompletableFuture and a thread we spawn explicitly and then completing that CompletableFuture inside that thread. So this is going to allow us to not use any explicit threading in our own code. And once again, you can find this in the EX8 folder. And once again, I show you what it looks like with a little interaction diagram. So the first thing we're going to do is we're going to say CompletableFuture.supplyAsync. So that's going ahead and calling supplyAsync on the CompletableFuture, and that goes ahead and queues up some stuff to run in the common fork join pool. And it's going to arrange to execute this supplier lambda in the context of the common fork join pool. That's what this supplyAsync method does. And here is, in fact, the supplier lambda. As you can see, as before, the supplier lambda is going to multiply two big fractions together. And these computations there, the computation here, the supplier lambda computation that's running in this background pool, can run concurrently with respect to anything that happens after supplyAsync is called. That's the ... you see here in the main program, or the call or part of the program. So these things can run concurrently. As with the previous example, after some point, the main thread of control can say, all right, I'm done with whatever else I can do. I'm now going to wait for the result to come back. And what will happen, of course, is after the multiplication takes place, that'll get returned through the result of the CompletableFuture. Notice that this example does not have to explicitly spawn any threads at all. So instead, what you're doing is you're simply calling supplyAsync, giving it a supplier lambda, and then that's passing that supplier lambda back for computational purposes to run in the context of the common fork join pool. So you aren't spawning any threads. There's already a pre-spawned pool of threads that you get out of the box for free as part of the common fork join pool. Likewise, unlike the previous example, there's no need to explicitly complete the future, since supplyAsync returns a completable future. When you call supplyAsync, you get back a completable future. And so there's no need for you to do any complete here. You simply return the result when you're done. And that will then find its way back to whoever's joining with it or whoever's ever waiting for the next stage in a completion stage if we happen to chain these things together, which we're not doing here, but we will do once we talk about completion stage methods. However, we still have our join call, and so we still have to figure out a way around that, which we will do again as we get further down the road. But this example is showing you how you can use factory methods, or a factory method, supplyAsync, in order to schedule computation, which is a supplier lambda, to run in a background thread in the common fork join pool. We get back a completable future, and then the calling thread can block or join on that when it can't make any more forward progress. And when the computation is done running in the common fork join pool, then that will arrange to trigger the completable future, thereby allowing the caller to be released so it can go on its merry way and print the results. So that's the end of our quick overview of showing how you can implement something using the factory methods in Java completable futures. Not surprisingly, there's a lot more to it than all of that, but I just wanted to give you a quick overview of factory methods first.